I'm Liz Snedden. Let's have a look at long-run relative frequencies. So when we talk about long run, it's looking at how my frequency changes, or in particular how my relative frequency changes over a lot of trials. So the first few times that I do something, I'm not going to be as good at it as by the time I've done it lots and lots, I'm going to get much better at it. And that's the same thing with when we run experiments, is that the first few times the probability is more uncertain, and as we go on and collect more and more data, do more and more trials, our accuracy is going to improve. We're going to get closer to the true probability. So here's an example of a long run frequency graph. And what I want you to just notice is if I was to draw kind of a line around the top points and then a line around these bottom points, what you should notice is that at the beginning there's a lot of variation. That's quite wide, those two lines I've drawn. As I do more and more trials, because across the bottom I've got my number of trials, as I do more and more trials, these lines are getting closer and closer together. And that's because the more data we have, the better our precision is going to be. And you'll notice that the blue line is getting closer and closer to this value of 0.5. So that's what the long run relative frequency would be, is what value that it's heading towards. So let's have a look at an example and actually do one in full. Okay, so I'm just going to do this one trial at a time. So this is just tossing a coin, and we know the probability of a head is 0.5, and I'm going to say add a line, so this green line here, this is the true probability. We know that it's the chance of a head on tossing a coin is 0.5. So now let's just actually go ahead and simulate this. Let's collect some experimental data. So I'm going to toss a coin first of all. And the first coin I tossed gave me a head. I can see there I've got one head at the top. So the probability of it is 1. Toss a coin a second time, and you notice this blue line's coming across the top there. I've got 2 heads. So 2 out of the 2 coins I've tossed are both heads, so my probability is 100%. Let's do a third one. Okay, now this one I've got was a tail, and I can see that now I've got 1 out of the 3 coins I've tossed as a tail. The fourth one was a head, so I've got now 3 heads and 1 tail. And as I go on, notice now what's happening to this line. Each time I toss a coin, it changes, but that line was first above the green line. Now it's gone below the green line, but it's as I do more and more, so I'm up to 27 trials now, as I do more and more trials, we should see our data getting closer and closer to the true probability of 0.5. So let me go up to 100 trials and let's see where we get. Okay, so just over 100. So I've done 101. So from this trial, you'll notice there I got 40 heads out of 101. So it's not quite that 50% probability. So what we can see there is it's not 100% accurate, is it? Every time we take a sample, every time we collect some data, do an experiment, we're going to get results that are close-ish to the true probability, but may not be exactly the same. Let me reset that. Let's try this again. So now I'm going to do, let's say, I'll do 100 all at once. And there it's gone, and it's doing 100 for me all as a big long hit. And we can see this line looks like it's got much closer. So now in this particular experiment, we got exactly 50 out of the 100 were heads. Let's try that another time. So you can see each graph looks slightly different, but they're all looking like they're heading down towards that. So this one's a little bit more, 52 out of 100. And if I was, let's do a fourth experiment, we can see each experiment we do is going to get slightly different data, slightly different results. Okay, so that one became 56 heads out of 100. So that's the kind of patterns that we will expect to see over time. Thanks very much for watching.